So, logarithms and logarithmic equations. When you think about logarithms or you see the word log or logarithm, you have to think that you're talking about exponents. That's all logarithm means, is the exponent. So, when we see this equation that y is the log base b of x, y is an exponent. So it's the exponent that makes the equation b to the y power equal to x. That's what this says right here. This takes a little bit of thinking over and over again to understand what a log is. In basic English, if we have log base b of x, you ask yourself, b to the what power will equal x? So b to some power, I don't know what power, is going to be x. So the other question is, what exponents does b need to have so that the answer equals x? That's going to take practice over and over again to think about what's a log? All right, it's an exponent. So, moving on. If I can find the button, there we go. This piece here, exponential and logarithmic equations, they're very much related. When I took Algebra 2, exponential and logarithmic equations was taught by a sub. My teacher was gone. They didn't know what they were doing. And I learned that I just needed to put these two little things on the top of my paper so I could always go, okay, if I know 2 to the third is 8, and I memorize how to write that as a log function or log equation, then I always have this sample. So here's how you do it. 2 is the base, that says base by the way, for the exponential function. 3 is the exponent. 8 we'll just call right now the answer, for lack of a better term. So to convert that to logarithmic functions, if you look at this, the base is 2. Here's the base. A log function is talking about the exponent. So the exponent here is 3. And the 8 is the answer. So my strategy, for a lack of understanding this stuff, was to just write those two things on the top of my paper so I always had one that I know I could figure out in my head that made sense, and then I could apply it to other situations. Hopefully you won't have to do that after a while after we do some practice. So, you're going to take exponential equations and change them to logarithmic, and log equations, like this one in example 1, and change it backwards, not backwards, but change it to exponential. So in exponential, we need a base. What's the base in log? Base 3 of 243 is 5. What's the base? 3. So we said logs are equals to exponents. So what's the exponent in log base 3 of 243 is 5?
5.
The 5. So 3 to the 5th should be the answer of 243. You pop out your calculator and you plug that in. Sure enough, 3 to the 5th is 243.
It's actually 244.
No, it's not. So, example 2. Write a log equation equivalent to this exponential one. So if we have to write a log equation, the first thing that's going to be in the log equation is the word log. Got that much? What's the base of this exponential equation? The base is 6. So log base 6, and this is just a subscript. It's lower and a little smaller. That's how we write the base. And we said logs are always equal to the exponent. What's the exponent in this?
ID.
negative 3. And then we put 216 here. So this is the log base 6 of 206, 1 over 216 is negative 3. And now you've done it. So there's a few more to practice here. I will do some of them, and in the next video we'll have the answers to those.